We are all very excited about the scheduled landing of Chandrayaan-3, India's moon mission at Moon's South Pole, day after tomorrow, August 23rd, at around 16:04 hours. And we have with us right now Professor Radhakant Padhi from the Department of Aerospace and Center for Cyber Physical Systems, Indian Institute of Science, Bangalore, to explain to us the landing process from now till the time the spacecraft Chandrayaan-3 Vikram lands on the designated site. Welcome, sir, and thank you for your time.
Thank you.
Thank you, sir. So, can you please take us through the journey from now till Vikram lands at the landing site, sir?
Well, now we already know that it's the final orbit on the moon. So from there onwards, that will go to a final journey. So this is, it will not be an orbit anymore. Once you, on August 23rd, they will give the final landing trajectory will be kind of initiated. So from there, you will have this very long segment called rough braking, and then followed by some attitude hold, fine braking, vertical landing, all sort of thing. The entire sequence is going to last for a few minutes only, and you will finally have the soft landing on the moon.
So what do you think is the success rate? I mean, we are all very hopeful and excited about it. But what do you think is the success rate of Chandrayaan-3?
Well, being involved in this project for some time now, I can always very confidently say that in my own assessment, the success is going to be, success possibility or probability is about 99.9%. I'm very confident that it will happen.
So we have learned a lot from Chandrayaan-2, isn't it? So how have we ruled out all those possibilities, the last minute possibilities of a possible mishap?
No, obviously there are a lot of learnings already there. I mean, lot of not only learning, the rectification, and that is much more important. And thanks to the ISRO team, they've worked very hard day and night to make sure that all these issues will never happen and beyond. So there are certain things that were learned from the mission and certain things that were anticipated beyond that, but was not there in that mission as well. So taken together, there are a lot of action items taken by ISRO, remedial measures, corrections, testings, rigorous testing, both software, hardware, everything. So I think I'm very confident that the mission is going to be very successful.
So is Vikram now on an autonomous travel, or still it is being controlled from ISRO here?
Now it's still being controlled from the so-called Earth station in ISRO or whatever. So as long as the spacecraft is in orbit, that is still under ground control. That means controlling from ISRO. But the moment they decide to get out of that and then go on the landing journey, that has to be completely autonomous. And that is why it is called 4 to 5 minutes of terror. Essentially, you don't know what is happening. You are simply looking at the screen. I mean, you can't really control it, anything. The reason being communication lag also. There's too much of communication, time lag and all that. So we can't really talk about taking a decision in an autonomous mode. Taking a decision manual mode. So rather you have to depend on the autonomous mode.
So you have spoken about the inbuilt salvage module. Can you kindly explain this to us?
Well, salvage module is something that was not really was a primary action item. And that action item was thought about in case some very so-called unknowns happens and things like that. So there are this known, unknown also things that happens there. So whatever is known unknown, that design caters for a large amount of perturbation study. Whatever is unknown, that even in simulations and everything, that is simply unknown. So you have not studied about that. In case such a thing happens, very rare chance, of course, but in case such a thing happens, then the whole idea is not to worry about the site of landing site for it. So you still want to have soft landing, you still want to have vertical landing, but landing site is not important anymore. So that will be left to the God to decide in some sense.
So are you telling us that even if it doesn't land at the designated site, it can still be a successful landing? Are you saying that, sir? How much can it deviate from the...
What happened is in a critical mission like that, there is a lot of study about proper landing site with less hazard. And this particular mission, there are two sites. And even if there is something called primary site and secondary site. Now, even if the lander doesn't land on the primary site, it actually decides to go to the secondary site because of this whatever capability there. it is still 100% success. That is by design, it is like that. Now, if it is, suppose it is not able to land even in the secondary site and it goes in a salvage mode, we don't know where it will land. All that the design tells is the velocity, final velocity will be 0 and vertical will be, I mean, more or less the attitude will be vertical. So landing site depends wherever the residual velocity, whichever direction it goes and things like that. If the God is with us, then obviously it will land in a proper way or proper site. If it is not there, then maybe it will land with a hazard site and things like that. Then there is a chance of the vehicle getting tumbled even after landing. So all these things are a possibility. But then that is something to have something better than nothing, basically. So, but
But
that
we
we
would still
don't.
have the studies. I mean, we would still have the analysis from.
Right. We do have a lot of analysis. I mean, not we, I mean, the ISRO has done quite a bit of a study on that. So eventually, that risk probability is always there. But remember, it was declared as a failure case already. Okay, so then only the salvage mode, I mean, kind of initiated. So whenever you talk about site 1 is not reachable, site 2 is not reachable. I mean, everything is going out of kind of not your control. And that is the only place where you want to excite it. Otherwise, if you are exciting in some sort of error, then even the good mission will become bad mission. So that should not happen. So that is also enough care has been taken not to do that, and that will happen only in extreme emergency case sort of things.
So have these sites been named? Have they been given any name?
There are names, but I'm not able to recall at the moment. This will be there in ISRO's website maybe. So
So also you spoke about the Six Sigma bounds, which is designed within. Can you please explain, sir?
well, what happens is, this we normally deal with a very natural probability distribution called Gaussian distribution. So in the Gaussian distribution, most of the things, whatever naturally appears, there are probability distribution theory and things like that. Many of the probability distribution theory rely on Gaussian distribution, which is described by something called mean value and variance and things like that. So variance is this called so-called sigma. So if you really talk about plus or minus 3 sigma around the mean value, then most of the cases you have already covered. That means a very, very high probability that you have covered all the cases in some sense, whatever expected bounds actually. Now, it so happens in the Gaussian distribution is a never-ending tail sort of thing. So the more and more, suppose you go 3 sigma to 4 sigma to 5 sigma to 6 sigma, then you are covering up that remaining tail probability as well. So that is why you now you're bound of, suppose your value is this one and then there is a dispersion around that 3 sigma bound. Now 6 sigma becomes double of that. And now it has become, it's a Gaussian curve, it's a kind of a bell-shaped curve. So essentially you are covering up all those extreme cases also in a very, very kind of probability, good probability sense that nothing will happen basically. So that way the testing part of it has been done with the 6 sigma bounds this time. So in other words, even if there are large perturbations of these so-called known perturbations essentially, then things will be not too much to be worried about. Things will be under control basically. So that is what is 6 sigma bound test.
So why have they been? Why do you think there have been at least two, like Chandrayaan-2 and Luna 25, crash landing at this particular South Pole? What may have gone wrong?
Well, there is nothing to be so much specific to best of my knowledge about South Pole. I don't think there is any mysterious thing there, like a very high magnetic thing or maybe very unnatural gravity and things. People can speculate many things, but normally those are not. Because remember, around Moon, several satellites are orbiting. And satellite orbits are based on the gravitational theory, magnetic field, all sort of things. These are all very, very well studied actually. And there even the moon surface, I mean, surface of the moon is extremely well studied because for years satellites are revolving around that. Nothing to be kind of concerned about that. But what happens is, always remember that South Pole, there is no desert land. Okay, so essentially there are too much of rocky land and the craters and things like that exist there. So land point of view is not a good thing. But remember, these are all crash landings. So people have, the satellites have not gone there and try to kind of skid away or kind of got merged in the mud and all of that. Those things are not there. So by nature, it also turns out to be a very critical kind of mission sort of thing. Like whenever you do this type of missions in autonomous mode, these are not really easy. So yeah, there are multiple constraints that keeps on coming. Suppose, for example, you go to a very hazard-free site, for example. You can simply go there and then take your own time to make the satellite vertical and simply go down. Doesn't matter because the large land is desert actually. That's what happens in the northern hemisphere part of the moon. But when you go to the southern hemisphere part of it, knowing that the landmass is not really in a good shape, you like to take all these extra precautions, and that makes the missions complicated. That brings on more complexity to the mission, more sensor to the mission. Sensor failure probability is more. Sensors may not work the way you want. Even if that data collection happens, there is something called lunar position detection camera. So essentially it takes a picture and then figures it out to where you are based on the crater location. Each and every crater is actually identified. So that may not function in real time. So there are many concerns like that for which the system may not function well. So that is the concern rather than anything else.
So what is it that we're looking at, the space scientists are looking at from Chandrayaan mission? What are the takeoffs?
Well, Chandrayaan mission has a very nice sensors actually, like whatever, there is a Progyan rover as well. So Progyan rover and lander, there are multiple sensors to study the moon's, first of all, soil composition. Whether the soil has some fertility or some soil has moisture, soil has bacteria, or what is it there actually, that way. So that is one curiosity that happens because soil nature can be very different from northern hemisphere to southern hemisphere. We all know that. So maybe there is a water content in the north side of that, and now it is established. Is it there in the southern part of it? Remember, it's not an ocean or anything like that. It is not that which is visible from the satellite. You have to go to that and soil composition you have to study and things like that. Actually. That is one aspect that is going to be people are very eagerly looking forward to. The primary reason is okay, if you really want to go there next time and want to generate oxygen out of it, then from water content you can generate oxygen. So it kind of helps you in some sort of habitat building and all that. That way. Number one. Number two, they also talk about magnetic distribution, magnetic field distribution and all that. So sometimes you can study about that. Number three, there is some concept of electrical charge distribution on the soil. So lunar soil is not really charge free and all that. It's electrical charge distribution. So they also want to study that part of it. There is a sensor for that as well. So like there are several missions, like several sensors like that, which will give us rich scientific data over whatever time it kind of executes the mission basically. So in this case, if it is arrival time is on the very early morning, then you can take care of at least about 14 days of time to study. So 14
coming
days,
to that,
14 of the days, what I mean.
Yeah, 14 Earth days. So I just wanted to talk to you about, is 14 Earth days enough for a scientific study of the moon?
Well, for a scientific person, if you are a scientist looking for the data, you would like this mission to be perpetual. So essentially, you can keep on doing and all that. So there are several things there actually, by the way. One thing is you can have a, let's say, imagine that there is a perpetual rover. I mean, it doesn't have any energy issue for some reason, whatever. Then also there are navigation issues. Suppose the vehicle topples for some reason, right? I mean, while going, it encounters a hazard or something, it topples. Now, how you take, there's nobody to kind of make it kind of back turn and then make it in a proper safe picture, right? So that itself is a failure. Even though you have energy, you still cannot operate the rover basically. So that is a possibility. Now, coming to the possibility of okay, suppose that is not there for some reason, then obviously you would like to have the rover or lander situation acting as long as possible, as much wide distance as possible. You would like to cover so that you will get different samples from different points of the location basically. So obviously that's a dream for every scientist, but from engineering technical limitation point of view, it may not be feasible. And the one reason happens to be the energy content. And remember, we do not have a nuclear source or anything like a fuel cell sitting on the either lander or rover. So once you don't have a fuel cell or something like a nuclear power, typically it goes to a nuclear, small nuclear power or something, power plant. Then it becomes infinite energy basically. So you really don't care about solar energy and all things like that after that. But we don't have that technology. Right now, we really rely on the solar technology, both in the rover as well as lander. So we do have a natural restriction of daytime sunlight.
So is the crashing of Luna 25 a kind of a setback to, scientific study or,
any crash of any nature is always a scientific setback to the entire humanity. So remember, this was not really on a defense mission or anything like that, to the best of my knowledge. So anything that you talk about by any country, basically, so it doesn't matter whichever country is that, with the data generation for scientific purpose remains very valuable actually. So that way, obviously, any crash landing from any country happens to be a setback for the entire humanity, including, the recent crash of 25 from Russia. Basically.
So what do you think of, and let's assume that we have already soft landed, fingers crossed. What is the next step after Chandrayaan-3 successful mission, sir?
Well, the very first thing that you like to see, is whether you can wake it up, the system. So I told about nuclear energy and all that. So that is possible in the next mission or whatever it is. I believe there is some some activity going on in consultation with various agencies of our country as well. There is some interest of ISRO doing that, but not at the right now. So what they've done to cater this problem to a limited success, or if at all is possible, to the best of my knowledge, is take a little bit of extra battery sort of thing. Energy source will be little more, energy storage will be little more. Now, if you are somehow like you are lucky or something like that, and then you obviously when the night comes, you will put everything on the sleep mode. And then when the day arrives, if you are able to wake them up, then you have another full day cycle, basically. Whether it will happen, most likely not, but let us hope for that, that way. Now, that is this mission part of it. Now, going forward, I think there is a huge amount of interest for human habitat in Moon. And that is where the NASA has a very big program for that. Even our great Elon Musk also has its program for both Moon and Mars and all that. So there is a long-term plan for the entire humanity for survival purpose and much beyond that. So also there is a belief that Moon and all asteroid bodies contain a lot of rich minerals and all. So they can also do mineral harvesting, something like a refueling station, something to kind of go there for tourism purpose. May happen also. So many of these things are happening worldwide.
So, how have we calculated that at this point, at say about 5:47 or 4 p.m., the sun will rise on the moon, on this particular side of the moon? How have the scientists come to this exact calculation?
So that is an amazing thing from the nature, by the way. So also I get amazed sometimes to see how the nature is organized by itself. So the moment as laymen, we see the sky, it is a very much of a puzzle. But if you get into the little bit of space science and things like that, the entire universe, at least the solar system, is extremely organized actually. That means, this our Earth days also, millions of years, we have the same 24-hour, same 12-hour cycle, all that actually. So everything is organized that way. So the moon also, moon's orbit, moon's rotational speed, and the moon direction, everything is well studied actually. So depending on which orbit you are going there, you can also have orbital period actually, right? How much time it takes to complete one orbit. So all these things can be deterministically known, and then that is how it is back calculated. So when you start and where you start and where you go, and all these are all possible. Of course, not easy. There are softwares available for that. You have to feed the proper data for that, and for that you really need to have good something called orbit determinism, where your satellite is at what point of time. So and that is very critical information in any orbit. So that for that we need to have very good accurate orbit determination. After that, more or less everything is. I mean, you can calculate not really very complicated, very rather easy way, basically.
So how excited are you people? We are all very excited, and I cannot imagine the excitement of the scientists who are involved in this mission.
Well, I mean, probably you know that by now, like wherever the Chandrayaan-2 had a problem, that soft landing segment part of it and all that, and that is where we had this initiation of so-called fine braking phase. There was a problem there. And that is where the guidance has been improved, and that guidance improvement part of it, the ideas, solutions, and all that, has primarily come from our lab, but largely developed jointly between our lab and ISRO. So obviously, we are interested more than anybody to see that happening, and then of course we are very excited to see that really happening on the screen. And for that, I'll be there in the Mission Control Center as well. I've been invited to witness that.
And where does Chandrayaan-3 mission put India on the global space map? I mean, both are,
It's a mission like that, more than anything else, it gives a lot of confidence to the nation and a lot of excitement because of that confidence building measure. There are a lot of, so now you can see the motivation level of all college, high school, starting from kids and all that is extremely high. So many of them may actually become space scientists later. And there are a lot of spin-off technologies. It's just not the assess. For example, you talk about, let's say, position detection camera, for example, one sensor. Once you validate it, it will be useful for all future missions, basically. And it can be useful for on Earth also, basically, right? So all these guidance philosophy of whatever you talk about soft landing, in fact, it is extremely good for drone soft landing. In fact, we have in our own lab, we have actually implemented that and then demonstrated that drones can soft land autonomously also, basically. So that gives us a momentum jump in the drone technology as well. So there are many things that can happen. And we are all looking very excited for seeing that. Future part, if you ask me, that is better known to ISRO. What they plan, whether there is Chandrayaan-4 mission or 5 mission or something, probably ISRO chairman will be in a good shape to talk about it. I don't know really in that part of it. But what I do know is there is a lot of interest for going to Mars one more time and probably having a Mars landing part of it as well. Some initial studies has been done as well. And then there is some degree of thought process to go to Venus as well. Venus is the other side of that actually. So
we also
there are,
have the Aditya L1 mission, sir.
Aditya L1 is also coming up. In fact, there also our lab has done some contribution already, basically. So, but that is not implemented in the mission. We are still debating whether that can be done, because you may remember Aditya L1 is sun pointing and sun observation sort of thing, basically. So it takes a lot of time to go there. So we are now talking about a 15 lakh kilometer separation, basically. The L1 point itself is from about 1.5 million or 15 lakh kilometer away. So it takes a lot of time. We have to go wait for that manifold to happen. All sort of things are there. So once you go there, then you want the satellite has to be there for as long as possible. And that is actually an unstable orbit. It is now, see, normally all these elliptic orbits are typically stable orbit. But the orbit around hollow orbit is first of all 3D, and it's a kind of one-dimensional unstable, things like that. So you really need a good station keeping to happen for your long duration observation, basically. So you keep on correcting the orbital corrections and all that periodically, so that you can stay there for a long time, basically. So that is one thing, but once you stay there, you have to keep on observing the sun also. So there is a lot of attitude control that's involved in that. And because the sun is too far away, the angle accuracy becomes in the form of 2-3 micro radian sort of thing. It's a very small angle. I mean, the angle accuracy is very, very high precision requirement. So that's a different mission. It's all ISRO is again excited about it. It is coming very soon, in fact. It'll come,
Yes.
The launch will happen on September 2nd, if I believe. So that is
Yes.
the current estimate date, basically. So we are all excited for that as well. We'd like to see that happening. But we have to wait until the satellite goes there, stabilizes, sends the picture, all sort of thing. That will take its own time.
I'm sure. And I'm sure, I hope to meet you day after tomorrow, sir. We are all going to be there at this track. And thank you so much for your time, sir.
Yeah, thank you very much.
All the best, sir. Thank you so much. So this was Professor Radhakant Padhi from the Department of Aerospace and Center for Cyber Physical Systems, Indian Institute of Science, Bangalore, explaining to the New Indian Express and its viewers, its audience, the landing process, that is now the countdown to Chandrayaan-3, which is supposed to soft land on the designated spot on Moon's South Pole day after tomorrow at 6 p.m. 6:04 p.m. IST on August 23rd. So we wish everybody good luck, and let's go and watch the countdown. Thank you so much.